Okay, so this is going to be a video on Unit 1, Topic 3 of Pre-Calculus, our unit test on rational functions. Let me explain what I already started writing and then I'll keep going. This minus 4 moves my horizontal asymptote down 4. So I have this horizontal asymptote down here at y equals -4. For the vertical asymptote, that is when the denominator equals 0. So if you wanted to, you could do this and solve it, and that's at x equals -1. And then for the graph, what I can do is look in my calculator. I could also figure out some of the other information first. I can do the translation. So this goes left 1 and down 4, and there is a vertical stretch of 3 because of the 3 in the numerator. The y-intercept is when x is 0. So if I plug 0 in, that's 3 minus 4, that's -1. So you can either write it as a coordinate or you can just write -1. It's right here. The x-intercept will be easier to do with my calculator. That is when the y is 0. No, I'll solve that. What the heck? So we're going to set the whole equation equal to 0. So I'm going to add 4 to the left. Make this into a fraction. We can cross multiply. Add 4. So that's 7/4. Or you could just write 7/4. You don't have to write the whole coordinate. Okay, because this point's here, I know this piece approaches those asymptotes, and this piece is down here. If you want, you can confirm that in your calculator. When you type that in, though, you need parentheses around the denominator for the whole expression to be considered in the denominator, and there is the graph. So my pieces are in the top right and bottom left. You can't really see the x-intercept well in the table. It's hard to see when y is 0. Like it doesn't, because these x's are integers and we know we got a fraction. So it's better to solve it like I did instead of using the calculator. So for end behavior, to the right, as x goes to infinity, y goes to, and it's always going to be the horizontal asymptote, -4 in this case. For left end behavior, as x goes to -infinity, y also goes to -4. We approach the horizontal asymptote. None, no holes. Domain is all reals, but x cannot equal -1. Range is all reals, y cannot equal -4. Okay, number 2. Ooh, we got some factoring. Let me do that over here. So there's a 2 in the numerator that we can factor out. And the denominator, what multiplies to 8 that adds to -6? -4 and -2. But I'm not done factoring. This numerator can factor again. It's the difference of 2 squares. Oh, a factor cancels. So there's a hole at 2 something. Okay, so our simplified function is 2 times x plus 2 over x minus 4. So I'm going to base everything off of this. Okay, well, let's finish with the whole. To get the coordinates, I need to plug 2 in. So let me just calculate it this way. -4 is the y coordinate of the whole. Looking here, the vertical asymptote will be at x equals 4. That's what makes the denominator 0. Comparing the degrees for my horizontal asymptote, if I make it a polynomial over a polynomial, my degrees are the same. So I divide my leading coefficients. That's 2 divided by 1. There's a hole at 2, 4, oh, negative 4. So I'm going to draw my hole. Okay, x-intercept is when the whole equation equals 0. So when does 0 equal 2x plus 4 divided by x minus 4? If we cross multiply, we get 0 equals 2x plus 4, and that happens at negative 2. The y-intercept is when we plug in 0. So that's going to be 4 over negative 4. It's negative 1. Oh, look, our shape is starting to pick up here. Can build it, skip over the hole. This shape. You can always look at it in your calculator. I'm going to do the original equation in the calculator. Parentheses around the numerator. Oops. Parentheses around the denominator. Graph. So that looks like what I drew. Now you can't see the hole, but watch this. If I hit trace and go to 2, there's no y value. It's missing. So even though the calculator doesn't visually show you this nice hole, it is really a missing point there. Okay, let's see what's next. More graphs. All right, up to, did it say translation? Oh man, I didn't finish my properties. Sorry, wait, go back. All right, end behavior. X goes to infinity, y goes to 2, x goes to negative infinity, y also goes to 2, both at the horizontal asymptote. No slants. Domain is all reals, x cannot be negative 2. The range, no, man, Miss Weiss, x can't be 4. Sorry. The range is all reals, y cannot be 2. All right, now we're done. Number 3. 2 is my horizontal asymptote. Always write it as an equation of a line. X equals 0 is the vertical, because that's what makes the denominator 0. So let's see. We're going to go up to reflect over the x-axis is this negative coefficient, and a vertical stretch of 3. We can graph it to see what it looks like. So my pieces are over here because of the reflection. Oh, let me figure out the x-intercept. 0 equals the entire equation for the x-intercept. Subtract the 2. Cross multiply. So the x-intercept's at 3 over 2. It's like right there. Okay. So for the end behavior, x goes to infinity. Our graph always approaches the horizontal asymptote for both. All reals, x can't be 0. All reals, y can't be 2 because of the asymptotes. Okay, ooh, we finally got a square denominator here, number 4. So we're gonna have a vertical asymptote at x equals negative 1. Because that's what makes the denominator 0. For the horizontal asymptote, it's not in polynomial form, so I'm not gonna compare the degrees. I mean, you could multiply it out and do x plus 1 times x plus 1, or you could just look at it in your calculator. We'll use our resources. Oh, or you can see there's no translation up or down, so the horizontal asymptote is going to stay at y equals 0 from the parent function. That's a better way to do it. There we go, y equals 0. So translations went left 1 and a vertical stretch of 3 because of the numerator. No slant asymptotes or holes, nothing canceled for factors. Oh, and we saw both pieces are above the asymptote because of the squared denominator. There will be no x-intercept because of the horizontal asymptote. Let's do y-intercept. That's when x is 0. So we do 3 over 0 plus 1 squared. That's 3. I can put that right there. And we'll approach both asymptotes nicely with my graph. End behavior, x goes to infinity, the graph goes to 0 because that is the horizontal asymptote, and also for left end behavior. Domain is all reals, x can't be -1, but the range is very different for this graph. Because we are all above the asymptote, the range is y is greater than 0. There's nothing below it. Okay, last problem. Yeah, number 5 is last one. The numerator factors. I can take out an x. Nothing cancels, so there is no holes. The degree, what should I do next? Let's do the vertical asymptote. The vertical asymptote is x equals -1 because that is where the denominator equals 0. Okay, for horizontal asymptote, the degree of the numerator is bigger than the degree of the denominator. So that means there is an oblique asymptote, not a horizontal. Now, for the quiz, before we had gotten to oblique asymptotes, we would have said there is no horizontal asymptote, none. Because the numerator degree is bigger than the denominator degree. Well, past the quiz, we're gonna learn about slant or oblique asymptotes, and we have to do some long division to find it. Or box method division, whatever your preference. So I'll do long division to start. Long division, we say, okay, 3x squared divided by x. So this is what we're gonna think. Get it, my thought bubble? All right, 3x squared divided by x is 3x. So that goes up here. Then we multiply. 3x times x is 3x squared. 3x times 1 is plus 3x. And then we subtract and bring down. And then we think again, -2x divided by x is -2. Subtract, so that's -2x. No, multiply. -2 times x is -2x, -2 times 1, subtract. The remainder does not matter. Our oblique asymptote is y equals 3x minus 2, up 3 over 1. Down 3 over 1. And I could, sketch that. What should we do next? Let's do y-intercept. That's when x is 0. So we're gonna get 0 plus 0 divided by 1. That's 0. For the x-intercept, we're gonna get 0 equal to the equation. We can cross multiply, so 0 times that is still 0, 1 times that. Then we can each factor equals 0. So we get 0 as one of the x-intercepts and -1/3 as the other. Let's sketch it. So if that's here, and then negative 1/3, super close there. Ooh, that's gonna be, all right, let's see what this looks like. Parentheses around the numerator, parentheses around the denominator. So you can see kind of how we approach the slant. There's a piece down here I can't see. I'm going to change my window to look further down. So see, now you can see this bottom piece that would be over here. So we're going to have this part of the graph and this part of the graph. Okay, as x goes to infinity, y goes to. So as x goes to infinity, y is going to infinity. As x goes to negative infinity, this way, y is going to negative infinity. Domain is all reals, x cannot be -1. And for the range, that's trickier. And I didn't teach this in class yet, so I'm not sure what our answer is gonna be. So you just have to, I can't pause while I'm recording, so you just have to wait a minute and I will stall with while I look up what we're gonna want that. Oh, don't worry about it. So, okay, so when we have a slant asymptote like this for the range, because we're skipping a bunch of values in here, it's kind of hard to see, okay, exactly what are you skipping over. So when there is an oblique asymptote like this question, we will not ask you for the range. Okay, I hope that was helpful. Good luck studying. Print a new, no, I take that back. Not good luck. Hard work pays off. Print another review and do the graphs again all by yourself with no help until you are confident in everything.